to graph secant and cosecant functions. And secant is the reciprocal of cosine. Whoops. Secant is the reciprocal of cosine, so 1 over cosine. And cosecant is the reciprocal of sine, so 1 over sine. So when we're graphing cosecant and secant, it's smart to start by graphing cosine or sine. So the first step is, if you're graphing secant, you're actually going to start by graphing the cosine function. If you're graphing cosecant, you're actually going to start by graphing the sine function. The second thing is you're going to draw dotted lines that represent your asymptotes. So basically, wherever your sine or cosine graph is equal to 0, or like where it touches the middle, like you have your max, you have your middle, and you have your min, wherever your sine or cosine function touches the middle line, that's where you're going to have an asymptote. And this makes sense because since secant is 1 over cosine, you can never have 0 in your denominator. So wherever cosine is equal to 0, secant is undefined, and you're going to have an asymptote there. So an example would be like, well, we know that sine of 0 is 0, so cosecant of 0 is undefined. Since cosecant of 0 is 1 over sine of 0, which is 1 over 0. So like cosecant of 0, you're going to have an asymptote, or like secant of pi over 2, since secant is 1 over cosine. Cosine of pi over 2 is 0, so this would be undefined. So you have to check for where your function would be undefined and draw asymptotes. Basically, it's wherever the sine or cosine function touches that middle line. And then finally, you're going to graph secant or cosine based off of those dotted lines, based off the asymptotes. So first we're going to start by graphing y equals cosecant of x. Our amplitude is 1, b is 1, period is 2 pi, didn't shift it left or right, didn't shift it up or down. Our pieces are each pi over 2. Let me just graph this quickly because by now we are pros at this. So the first thing is I'm going to graph the sine function. So sine starts in the middle, and then it goes up. And it goes back in the middle. And it goes down to the bottom. And just graph sine with the dotted line, because it isn't actually what we're graphing. And it goes down, and then all right, so that is our sine function. Now we're going to graph our asymptotes. So we have asymptotes wherever our sine function crosses the middle line, okay, the x-axis. So I have an asymptote here at negative 2 pi. I have an asymptote at negative pi. I have an asymptote at the y-axis. I have an asymptote at pi. I have an asymptote at 2 pi. So now I've graphed my asymptotes. So now I'm going to graph my cosecant function. Basically, you graph it in between the asymptotes in the opposite direction. So here's your cosecant function, wherever it's in red. All right, now we're going to graph the secant function. Again, you start by graphing the cosine function, which has amplitude of 1, didn't shift it up or down at all, period of 2 pi, so all the pieces are pi over 2, pi, 3 pi over 2, 2 pi, and in the opposite direction. Okay, cosine starts at the top, goes to the middle, down, middle, top, to smile because it's positive. Okay, I graphed my cosine function. Now I'm going to go graph my asymptotes. So my asymptotes, wherever my cosine function passes that middle line, so and then asymptote at maybe 3 pi over 2. I'm going to have an asymptote at negative pi over 2, an asymptote at pi over 2, and an asymptote at 3 pi over 2. So now when I go graph my secant function, that, basically like you just follow along the asymptotes. And there we go, that is the secant function.